Hello, in this video I'm going to be going over the combined gas law. Combined gas law is pressure 1 times volume 1 divided by temperature 1 equals pressure 2 times volume 2 divided by temperature 2. And again, like all the gas laws, we need to make sure our temperature is in Kelvin, because it's based off of the movement of molecules. 0 Kelvin is absolute zero when molecules are not moving at all. And it'd be really good to memorize these gas laws. It's going to make your assessments that much easier. But instead of memorizing all of the gas laws, why not just memorize one? And if you memorize the combined gas law, you actually have all of the other gas laws memorized also. So if we just get rid of this temperature is constant, what we have here is pressure 1 times volume 1 equals pressure 2 times volume 2. That's Boyle's law. If we get rid of the pressure, moving that guy out of there, it's volume 1 over temperature 1 equals volume 2 over temperature 2. That's Charles' law. And if you get rid of the volume, you have pressure 1 over temperature 1 equals pressure 2 over temperature 2. And that's Gilusik's law. So really, if you memorize combined gas law, you have all the gas laws memorized. So let's do a problem. We have question 1. We have all of these little bits of information, our pressure 1, volume 1, temperature 1, pressure 2, temperature 2, and we're missing volume 2. That's what we're looking for. So I'm going to plug this in. We've got 1.5 atm is our pressure 1. Our volume 1 is 3.0 liters. We're dividing it by our temperature 1, but that's in Celsius. We need to add 273 to that to put into Kelvin, so that gives us 293 Kelvin. And this equals our pressure 2, 2.5 atm, multiplied by our volume 2, which is our X, what we're looking for, and then 30 Celsius, but got to be converted in Kelvin. We add 273, and that's going to be our bottom number. So 273 plus 30 is going to be 303 Kelvin. Alright, so we have our setup. Now all we have to do is plug and chug, put it in our calculator. That can be sometimes the place that students make the easiest mistakes. So you always want to show your work, just as an insurance policy. We got 1.5 atm times 3. There's multiple ways to solve this. I'm going to solve it the cross-multiplying way, because that's the way that I like doing it. So 1.5 times 3 times 303. The best way to solve this is to use your calculator that you bring to chemistry class every single day. We have 1.5 times 3 times 303. That's 1363.5. 1363.5 equals, and I'm going to take my 293 times 2.5 times my V2 equals 732.5 V2. Then I want to isolate my V2, so I divide both sides by 732.5, 732.5. Those guys cancel out. 16. 1363.5 divided by 732.5 gives me 1.86. 1.86, and it's in volume. My original volume was in liters, so my final volume will also be in liters. And I now have to double check sig figs. Got 2 sig figs, 2 sig figs, 2 sig figs, 3 sig figs, 3 sig figs. Technically, they're saying that we have 2 sig figs with that line. They're saying it's significant, even though it's not. There should be a decimal there. That would make it easier. So I need to round my answer to 2 sig figs, so this 6 is going to round this 8 up, so I have 1.9 liters as my final answer. And that's how I utilize the combined gas law to find an unknown.